So let's start with a simple example. A firm trying to decide how much, say, food to build or to produce given the prices that are out there, okay? And we'll make this simple. Let's say this is a short-run problem. And so the firm has this kind of production function. The amount of food they can build is 2 times k to the 1/2 times L to the 1/2. And this is what we, this is kind of a Cobb-Douglas production function, and we're going to assume that this is fixed in the short run, and we're going to pick a really easy level of just 1, okay? So that means that in the short run, the production function is really just this, okay? And if the firm is facing a price of P for food, and it has a wage rate W, and a rental rate of capital R, the profit function we know from before is PF times 2 times L to the 1/2 minus R, which is, well, times 1, that's the cost of capital, minus W times L, okay? And since this is a short-run profit function, we take the derivative with respect to L, and we get that PF, we have a 2, multiply that by the 1/2 exponent, we end up with just LF to the negative 1/2. No L's here, so that has a derivative of 0, minus W is equal to 0. Okay? And then we can rearrange this a little bit. PF over W is equal to 1, well, no, that's not right. Let's just do it carefully. PF times LF to the negative 1/2 is equal to W. Divide everything by W, multiply everything by LF to the 1/2, and we get LF to the 1/2 is equal to PF over W, or LF is equal to PF over W squared, because we have to square it to get rid of this 1/2 term. We square both sides. And then we're almost to the point where now we can figure out that, well, the amount of quantity they want, we take this and we plug it back into our production function, and we can get a quantity as a function of price and the wage rate. Okay, so 2 times, they've got just 1 unit of capital, PF over W squared. Okay, and this is basically a supply curve, okay? It tells us how much quantity the firm is going to produce as we change the price. And if we said the wage was equal to 1, for example, then we can see it's only equal to the price. And we can sort of generate our nice figure, and it looks like, in this case, it would look sort of like this. Here's QF. I'm sorry, we do the prices on this axis. So here's PF, here's QF, and it would look something like this. Okay? All right, easy enough. Now, that's easy enough to do when there's just one good, and we can figure out a sort of supply curve from that. But there's a way that is going to initially seem more complicated, but is in the long run going to be easier for us. Okay? And that's to break the problem of a firm into 2 steps. Profit max in 2 steps. The first step is cost minimization. Okay, so what that means is rather than figuring out, writing the profit function down and so on, we say, we derive a function that is essentially the answer to this question. For any Q, what is the minimum cost to produce Q? If you use your resources really efficiently, how does that work? To produce Q. Okay? And then once we have that, this thing is called a cost function. And it looks like this. It's a little c with a q in it, and it tells us if you have any q, what's the cost to make it if you operate as efficiently as possible. Okay? And once we have that, we go to step 2, which is how much Q to produce to maximize profit. And let me show you why this is a little bit simpler in the long run. The profit maximization problem, when you have a cost function, looks like this. Price times quantity, that's your revenue, minus the cost to produce that quantity, okay? There's only one choice variable here, okay? We take the derivative with respect to Q, and we get P minus the derivative of this is equal to 0, okay? And that's in 2 lines. I've basically already solved the problem. And the reason I can do that is because I actually did all the work in step 1, okay? But what's going to happen is that in a lot of economics, we just jump straight to step 2. So I give you a cost function, or we assume a cost function, and we don't actually go through the process of step 1. We're going to learn how to do step 1 now because you need to see where this stuff comes from, but that's the gist of it, okay? And this cost function is a problem of minimizing something with a constraint, okay? You need to minimize your cost. And if we're trying to minimize the cost of producing something, well, we should just produce nothing, and then it would be free to do that, maybe. Maybe not actually, but let's assume it is. But we can't do that. We're told you have to at least produce Q, okay? And so that means that our choices are constrained for all the, we have to use capital and labor in such a way that it's going to produce at least Q. And we want to find the lowest cost way to do that. So this is a problem where we're trying to minimize something subject to a constraint. And that is a situation that calls, once again, for the Lagrangian function.